All right, welcome back. We are in the home stretch. We are in our practice questions for our last topic. So, similar to how we've done before, this video is going to follow along with your homework sheet for percent with a P. Homework number 1. So this homework sheet is 2 questions. I'm going to do the first page, and I'm going to release you guys to do the second page. It would be a really good idea to pause it, try it, check your work. And if you're good, you shouldn't need to watch the video. You can just go ahead and go on to that second homework sheet. The new skill is not difficult. The new skill is just the last 2 lines. Everything else is just combining everything we did with density when applicable with what we know about moles and grams and mole conversions with stoichiometry and limiting reactants. We're just adding those last 2 lines. But this is percent yield, and it is homework number 1. And for this homework, I gave you a chemical reaction with barium oxide reacting with cesium phosphate to form barium phosphate, Ba3 PO4, and cesium oxide. Okay, so we start off, we've got a balanced chemical reaction. No, we don't. We don't have a balanced chemical reaction, but we are going to begin with 250 grams of each reactant. At the conclusion of the lab, 75 grams of each product are collected. So I've got 2 initials and I've got 2 actuals. Set up the table. Same thing we've been doing. So we're going to pull out molar mass and calculate our limiting reactant for the reaction using our initial mass and our calculated theoretical yield, comparing it to our actual yield, which will allow us to calculate our percent. So we need a balanced chemical reaction. I'll balance it in a minute. Barium oxide. Ba3 PO4. Oop, that needs a 2. Sorry, that one needs a 2. So make sure you fix that on your top one. That way you catch the balancing. And Ce2O3. So BaO, CePO4, Ba3, PO42, Ce2. Good. Okay, so go ahead and fill in our balancing. So let's see, barium, I've got 1 and then I've got 3. So I'm going to need a 3 out in front here. It's wrong color. It's not my balancing color. And 2, 1, 1. So balance the chemical reaction. Go ahead and start filling out what you know. Now, molar masses, I'm not going to go through how to calculate this. We should have this by now. But barium, 153 grams per mole. Cesium phosphate is 235 grams per mole. Barium phosphate is 602 grams per mole, and cerium oxide is 328 grams per mole. Okay, so molar masses I can know, limiting out to calculate, initial I can fill in. So I know that I start with 250 grams of each reactant. I don't have any initial products. Theoretical, I calculate. Actual yield, I know I end with 75 grams of each product, and we don't do actual yields of reactants. So what I need to do is calculate my theoretical yields and my percent yields. Well, out of colors. I'll make it green. So I've got 6 blanks that I'm going to need to do some calculations for. None of them can be done until I get that limiting reactant. So step 1 has to be limiting reactant. All right, so limiting reactant. I work left to right, so I'll do barium oxide first. Start with 250 grams of the BaO. From grams to moles, using the molar mass, so 153. So 250 divide 153. I end up with 1.63 moles of barium oxide. Divide that by my coefficient, which in this case is 3. And my value for barium oxide is 0.545. Do the same thing for cesium phosphate. So I begin with 250 grams. Grams to moles. Using the molar mass, which is 235. 250 divide 235. I end up with 1.06 moles of the CePO4. Divide that by the coefficient, which is 2. And I end up with, they're very close, 0.532 as a value here. They are close, but cesium is slightly smaller. So cesium is going to run out first. And cesium is going to be our limiting reactant, which means our theoretical yield of cesium is 0 grams. Now I can go through and calculate my theoretical yields for the others. So I start with the excess. So I'm going to start off with the BaO. So the mass, that's crooked, of the excess reactant. Our excess reactant is BaO, barium oxide. And we are going to use our limiting reactant. So I start with 250 grams of the CePO4. From grams of CePO4 to moles of CePO4. 1 mole contains 235 grams. From moles of one substance to moles of another. This time I'm going to barium oxide. and from moles of that substance to my end goal, which is grams of that substance. So I'm going to throw in my mole conversions. So that's my coefficients. I use 2 cerium phosphates to make per every 3 barium oxides. Using the molar mass of barium oxide, 1 mole contains 153 grams. All right, so go ahead, type it in. 250, divide 235 times 3, divide 2, times 153. I end up with 244 grams of barium oxide consumed. This should be, and you can kind of double check, since these numbers were so close, we're going to use almost all of it. We started with, that scared me. We started with 250, ended with 244. So that means we are going to have, you can probably do that in your head, 250 minus 244, we're going to have 6. 6 grams of excess barium oxide. Now I just need to calculate the mass of my products. So the mass of my products produced, I'm going to do the barium phosphate first. So barium phosphate, all these calculations are going to start off the exact same. So using the cerium as our limiting, 250 grams of the CePO4, grams to moles, using the molar mass, so 1 mole contains 235 grams. Moles of one substance, 2 moles of another. This time I'm going to the barium, Ba3PO4, 2. And from moles, that's a long label, of the Ba3PO4, 2, I can go to grams of the Ba3PO4, 2. Okay, so coefficients, I'm going to use 2 ceriums to make 1 barium, so 1/2. And the molar mass of barium phosphate is 602. Yep. Pulling all those numbers from our table. Go ahead, we can type that into a calculator. 250 divide 235 divide 2 times 602. And I end up with, I am going to produce 320 grams of the barium phosphate. So for theoretical yield of my products, I think I'm going to get 320 grams of barium phosphate. My other product is cerium oxide, Ce2O3. It's going to start off the exact same. So 250 grams of CePO4, grams to moles, using the molar mass, moles of one substance, 2 moles of another. This time I'm going to the cerium oxide. And from moles of that substance, I can go to grams of that substance. These are the coefficients from out front. So Ce is 2. Oopsie. let's see. Oh, the CEP04 is 2. No, I'm good. The CE203, the labels are kind of looking similar, is a 1. Yep. And the cerium oxide over here, using that molar mass, 1 mole contains 328 grams. Type that into a calculator, 250 divide 235, divide 2 times 328. And I am going to end up with 174 grams of cerium oxide. So 174 grams of the CE203. Now, I know in the last video we said that percent yield is usually the same. This time, since it gave you 2 collected masses, you can go ahead and calculate the percent yield. Those numbers are going to be different this time, but they're going to be actual, which is 75, divided by theoretical, which is 320 for the barium. So this percent yield is a 23.4%. And cerium oxide, 75 divide 174 would be a 43.1%. So this would be our percent yields. Do go ahead and you should show your work. I didn't, but go ahead on a test or quiz. You would need to show your work. So you could just throw that at the bottom of the page. I'll throw them while I'm talking. These calculations are really short, but we did it for BA3, PO4, 2. That one was the 75 divided by 320 times 100, and then the CE302, CE203 was the 75 divide 174 times 100. So that would be your work for percent yield. I want you to go ahead and complete page 2. So go ahead and do the calculations necessary for the second page of percent yield homework number 1.